Namaste and welcome everyone to Unit 3 of Chemical Engineering Plant Economics. In the previous unit, we studied how a chemical plant project is developed, from identifying the need for a project to preparing flow diagrams and selecting a suitable process. In this unit, we will learn how engineers select equipment for a chemical plant. Equipment selection is one of the most critical stages of plant design because it directly affects production capacity, product quality, plant safety, energy consumption, maintenance cost, and overall profitability. A poorly selected equipment may result in frequent breakdowns, increased operating expenses, and unsafe working conditions. Throughout this chapter, we will study the selection of materials, preparation of specification sheets, comparison between standard and special equipments, selection criteria of different types of process equipments, piping systems, and insulation. These concepts are widely used in chemical, petrochemical, pharmaceutical, fertilizers, and food processing industries. Before selecting any equipment, we must first decide what material it should be made of. Let us begin with the selection of material. The first step in designing any process equipment is selecting the correct material of construction. The material chosen determines the equipment's strength, durability, safety, and service life. Chemical process equipment operates under challenging conditions such as high temperatures, high pressures, corrosive chemicals, abrasive solids, and continuous operation. If the wrong material is selected, corrosion, leakage, contamination, or even catastrophic failure may occur. Certain basic criteria for selection of material include corrosion resistance, mechanical strength such as yield strength, ultimate strength, tensile strength, compressive strength, etc., operating temperature and pressure, chemical compatibility, physical and thermal properties such as density, viscosity, heat transfer coefficient, thermal expansion, and others, fabrication and weldability, cost and availability, maintenance and service life, safety and environmental considerations, codes and standards, product purity, abrasion and wear resistance, and lastly, industrial experience. For example, carbon steel is economical and widely used, but it is unstable for handling strong acids. Stainless steel offers better corrosion resistance and is therefore preferred in food, pharmaceutical, and many chemical industries. In highly corrosive environments, materials like fiber reinforced plastic or glass lined steel may be required. Therefore, engineers must balance technical performance with economic feasibility before finalizing the material. Let us take an example over here. A storage tank of hydrochloric acid is generally made of fiber reinforced plastic or rubber lined steel rather than ordinary carbon steel because carbon steel corrodes rapidly in acidic condition. Similarly, you can think of why stainless steel is preferred for pharmaceutical equipment instead of mild steel. Now, let us understand the various factors engineers consider while selection of material. Now, equipment selection is not a random process. Chemical engineers follow a structured approach to ensure that selected equipments perform efficiently through its expected life. The first stage is preliminary selection, where information is collected from previous industrial experience, equipment manufacturers' data, technical literature, and standard engineering references. Other methods to incorporate or get available data are preliminary tests that you can do in your laboratory also. Then second stage is laboratory testing, wherein revaluation of apparently suitable materials with test pieces included in laboratory runs of the process. So where suitable material and equipment are evaluated under actual process conditions to verify their performances. So that is why you do a laboratory testing. The third condition is that we engineers analyze all the technical and economic data before making final decision. At this stage, they compare equipment based on operating efficiency, Okay, so interpret laboratory results other than other data in terms of plant operation and considering presence of air in equipment, possibility of impurities, segregation of alloy constituents, fabrication method, avoidance of electrolysis, effect of temperature, effect of method of heating, effect of agitation. Then compare economic features of apparently suitable materials such as material cost, production cost, probable life lost, time cost, cost of product degradation, liability to special hazards, and lastly determine need for semi-works check of data. This systematic approach minimizes design errors and ensures optimum plant performance. After selecting a suitable equipment, engineers prepare an important engineering document. So now we will go through selection of process equipment. So we will first of all define how do we select a process equipment. So process equipment selection is a systematic process of choosing the most suitable equipment for carrying out a specific chemical process based on technical, economical, operational, safety and environmental conditions. The selected equipment should perform the desired operation efficiently, safely, economically, and reliably through its expected service life. This is very understandable thing. Okay. Now, what are the criteria for good equipment selection? The first one is that selected equipment should have high efficiency, low operating cost, long service life, low maintenance, safe operation, easy installation, standardized design, easy availability of spare parts, and compliance with standards such as ASME, IS, and API. What are the objectives of equipment selection if we talk about? Then the objectives include to achieve the desired production capacity, to obtain the required product quality, to ensure safe and reliable operation, to minimize capital and operating cost, to reduce maintenance requirements, to maximize process efficiency, to provide flexibility for future expansion, to comply with environmental and safety regulations. And what are the importance in terms? Again, it should ensure continuous production, improve product quality, reduce operating and maintenance cost, minimize energy consumption, increase equipment life, reduces plant downtime, improves worker safety, enhances overall profitability. Okay, so these are the reasons for uh, selection of equipment planning that we need to do. Now, equipment specification sheet. So a specification sheet is one of the most important documents used during equipment procurement and plant construction. It clearly defines the technical and mechanical requirement of equipment so that manufacturer can design and supply the correct equipment. So whenever you are designing an equipment, okay, so you need to have something in which you can put on the idea or your thought regarding the equipment, or you can mention the criteria that you need for your equipment. So that we do in a equipment specification sheet. Okay. Just in case if this sheet is not visible to you um, on your screens, don't worry. I'll try to attach this in the in the attachment section of this video. You can find it there also. Typical specification sheet includes 7 major sections. Okay, there are 7 parts. So the first one is contains project details such as plant name and project identification. The second one describes equipment including type, capacity, and service. The next sections that specify operating conditions like temperature, pressure, flow rate, followed by design conditions like material of construction, dimensions, corrosion allowance, insurance requirement, and then it also has auxiliary utilities such as steam, and the final specification sheet includes equipment life, inspection requirements, and applicable engineering standards. So like this wise, we have so many parts. A properly prepared specification sheet eliminates ambiguity, that is confusion, ensures uniformity among vendors, and simplifies installation, operation, and maintenance processes. Okay, a specification sheet, as simple as it looks like, it's a really important piece of information. Okay, and you need this piece of information, like if you have one equipment, you have even procured that equipment, but you might need this specification sheet till you are using that particular equipment. Okay, it is that important. So the so now next year we will try to understand what is the difference between a standard equipment and a special equipment. Okay, equipment used in chemical plants can either be standard, available in market in standard sizes and specifications, or special, that is custom designed for particular service. The selection depends on process requirements, operating conditions and economics. Okay, so this is a very thorough difference between standard and special equipment. I just take a brief. I want this particular section that you go through yourself and understand. It is very easy and very simple, but I want you to go and understand this. However, I will quickly take up. See, standard equipment is manufactured in standard sizes and specifications by several manufacturers. It is readily available, economical, easy to install, and replacement parts are easily obtainable. On the other hand, special equipment is custom designed to meet unique process requirements. It is used when standard equipment cannot provide desired operating conditions. Special equipment generally involves higher design and fabrication cost and longer delivery times. Okay, whenever possible, engineers prefer standard equipment because it reduces capital cost, simplifies maintenance, and minimizes procurement time. However, for critical and innovative processes, specially designed equipments become essential. For example, a centrifuge pump for water service is standard equipment, whereas a glass line reactor used in a pharmaceutical manufacturing is a special equipment. Okay, so this is what see what do you, when you need to choose between standard and special equipment, what criteria you look for. The first one is you look for cost. So standard, it is lower in cost, special it is higher. Availability, standard is readily available, special equipment takes time in delivery. Maintenance, it is easier in standard equipment, it is mostly difficult in special equipment. Flexibility, in standard equipment flexibility is limited. However, if you're designing, if you have a special equipment, you can give provision as much as you want for flexibility. And last one is suitability. For all the general services we go with standard equipment, for all the special services we go with the special equipments. Okay, so these points I have already concluded, I have already taken here. Okay, remember that the right equipment selection is equal to safe operation, high efficiency and low cost. I hope this is clear. If you have any doubt, you can put it in the comment section. Now, selection criteria for size reduction equipment. Size reduction is common operation in chemical industries where large solid particles are reduced to smaller sizes using crushers, grinders or mills. The selection of size reduction equipment depends on preliminary on nature of material, whether the material is hard, soft, brittle, fibrous or abrasive. Feed size, okay, the initial size of the material and the final product size that you need. Production capacity, that is how much capacity or throughput you need. Then moisture content, whether your material is wet, sticky or is dry. Then energy consumption, okay, that is also need to be taken care. We always focus on, or we always want an equipment which requires minimum power consumption. Then we look for wear and abrasion, that our equipment should be resistant to wear and abrasion because of the material crushing. One is maintenance requirement, that is easy maintenance and availability of spare parts along with cost and safety considerations. For example, a jaw crusher is generally used for coarse crushing of limestone, while a ball mill is used for producing fine cement powder. Okay, now let me ask you a question. Which equipment would you choose for grinding a hard mineral into fine powder? Okay, so that you have to answer in the comment section, that if your material is hard, okay, okay, and then you need to convert into fine powder. So what kind of equipment will you use? Now, after size reduction, many chemical processes require heating or cooling or both. Therefore, the next step is selecting suitable heat transfer equipment. Heat transfer equipment is used to transfer heat between two fluids without mixing them. Common examples include shell and tube heat exchangers, plate heat exchangers, condensers, and evaporators. The most important selection criteria is heat duty, which represents the amount of heat transferred. Engineers also consider operating temperatures and pressures, okay, because this design strength of the equipment. Then nature of fluid, whether the fluid a process fluid you want to heat is corrosive, viscous, clean, or fouling. Then you also look for heat transfer area, okay. Then pressure drop, material of construction, maintenance and cleaning, cost, safety, and reliability. The objective of achieve efficient heat transfer while minimizing the energy consumption and maintenance that you do. Now, besides processing fluids, industries also need to transport raw materials and finished product. This brings us to the material handling equipment. Now, material handling equipment is used to transport solids, liquids, powders, granules, and slurries within a process plant. Examples include conveyors, bucket elevators, screw conveyors, cranes, forklifts, and pneumatic conveying systems. The selection begins with understanding the nature of material, whether your material that you want to transfer is solid, liquid, powder, granule, or slurry. Then material characteristic. What is the size of the material, shape of the material, density, if it is abrasive or not. Okay, what is the moisture content? Then handling capacity, quantity of material to be transported, distance and direction, whether you want to travel it horizontally or vertically or inclined, and to what distance. Then method of handling, whether you want a continuous process or a batch process. Then power requirement, that is energy needed for the operation. Last one is maintenance requirements, and again safety and cost follows. Also, sometimes you need to look into the availability of space. Okay. Now, proper material handling improves productivity, reduces product losses, and ensures safe plant operations. For example, in cement plants, belt conveyor transports limestone, whereas pneumatic conveyors are commonly used for fine cement powder. So, you see, as soon as the product, your chemical or your substance changes, okay, your even equipment changes. Many chemical processes also involve separation of components. So now let us discuss the selection of mass transfer equipment. Mass transfer equipment is used whenever one component is transferred from one phase to another. For example, it includes distillation column, absorption towers, extraction column, drying equipment, and absorption unit. The first selection criteria is type of mass transfer operations being performed. Then you need to look after the required separation efficiency, that is the desired product purity or recovery. Then obviously operating temperature and pressure, operating conditions, fluid properties, density, viscosity, volatility, corrosiveness, flow rate of both, if we have two phases, both liquid and gas flow capacities, pressure drop, material of construction that should be compatible with process fluids, maintenance and accessibility with ease of cleaning and inspection, cost, okay, low capital and operating expenses, and safety and environmental regulations. Selecting the right equipment improves the product quality, increases recovery, and minimizes energy consumption. The final equipment category in this section is pumps, which are essential for transporting liquids throughout a chemical plant. So pumps are among the most frequently used equipment in chemical industries. Their primary function is to transport liquids from one location to another by increasing the fluid pressure. The most important factor in pump selection is type of fluid. Okay, so whether your fluid is clean, viscous, corrosive, abrasive, or slurry, then what is the flow rate or volume of the fluid to be pumped, then the total head, that is height or pressure against which the pump operates, then NPSH required at suction, okay, to prevent cavitation. Obviously, operating temperature and pressure plays a role. Pump efficiency, high efficiency to reduce energy consumption. Material of construction should be suitable with the pump fluid. Maintenance requirement should be easy, low cost, reliability and safety against continuous leak-free and dependable operations. Selecting the correct pump involves plant efficiency, reduced maintenance, and lower energy consumption. For example, centrifugal pumps are commonly used for pumping water, while positive displacement pumps are preferred for transporting highly viscous liquids such as syrups and oils. In the next part of this chapter, we will be studying about piping system. Okay, but before that, this is a quick memory table for you where you can go through for remembering what are the major selection criteria. Okay, so if you remember this, you can write your answers in the examination. Now next part, okay, after understanding the selection of major process equipment, we will now study piping, which is often referred to as circulatory system of a chemical plant. Okay, so piping is an essential component of every chemical plant. It forms the network through which liquids, gases, vapors, slurry, and chemicals are transported between different process equipment such as reactors, heat exchangers, pumps, storage tank, and distillation columns. An efficient pumping system ensures safe, reliable, and economical transportation of process fluids while minimizing pressure losses and maintenance requirements. In short, if I say that the piping system is a system of pipes, fitting valves, flanges, supports, and other accessories used to transport fluids safely from one location to another within a process plant. Now, objectives of the piping system. The objectives include transport of process fluid safely, obviously, maintain the required flow rate and pressure, minimize pressure losses, prevent leakage and contamination, facilitate plant operation and maintenance, ensure safe and economical plant operations. Now, components of a piping system. So, piping system is not just about pipes. It also includes pipe fittings such as elbows, tees, reducers, couplings, valves, flanges, gaskets, pipe supports and hangers, expansion joints, and insulation. And the function of pipings include transportation of liquid, gases, vapors, slurries, etc. Connect process equipments, control and regulate flow rate, maintain process pressure and temperature, and facilitate maintenance and plant shutdown. Now, what are the factors affecting pipe selection? The nature of fluid, whether the fluid is corrosive, non-corrosive, toxic, hazardous, non-toxic, viscosity, and density also plays the role. Then operating pressure at high pressure systems require stronger pipes with thicker walls. Operating temperature, pipe materials must retain their strength at the operating temperature. It determines the required pipe diameter. Corrosion resistant materials should resist chemical attack to ensure long service life. Okay, pipe should withstand internal pressure, external loads, and vibrations. The selection should consider both installation and maintenance cost. And lastly, pipe should allow easy inspection, cleaning, and replacement. So these are the various factors that we consider for pipe selection. Okay, ultimately the selected pipe should safely transport the process fluid throughout the plant while minimizing the operating and maintenance costs. Okay, once the pipe is selected, engineers must ensure that it can safely withstand the operating pressure. This brings us to the pipe strength. So pipe strength refers to the ability of the pipe to safely withstand internal pressure, external loads, vibration and thermal stresses without failure or permanent deformation. Factors affecting pipe strength include material of construction, pipe wall thickness, internal pressure, pipe diameter, operating temperature, corrosion allowances, and manufacturing quality. Okay, also if there is some external loading and support, then that also affects the pipe strength. Okay, what is the importance of pipe strength? It prevents pipe from bursting, that is, pipe does not break, it ensures safe operation, it reduces maintenance, it increases the service life and maintains plant reliability. An adequately designed pipe prevents bursting, leakage, and mechanical failure, thereby ensuring reliable plant operations. To standardize wall thickness section, engineers use a system known as pipe schedule. Now, pipe wall thickness is distance between the inner and the outer surfaces of the pipe. It determines the pressure bearing capacity and the mechanical strength of the pipe. Factors affecting wall thickness include internal pressure, pipe diameter, material strength, corrosion allowance, operating temperature, and manufacturability. Importance of wall thickness is it withstands internal pressure, resists corrosion, improves mechanical strength, it prevents pipe leakage and increases the equipment life. So this is why wall thickness is equally important. Okay. A thicker wall enables the pipe to withstand higher internal pressures and provide additional corrosion resistance during long-term service. However, thicker pipes also have heavier and more expensive. Therefore, engineers must balance safety and economy while selecting the wall thickness. Yeah. To standardize the wall thickness, The selection engineers use a system known as pipe schedule. So a pipe schedule is a standardized designation that indicates the wall thickness of a pipe for a given nominal diameter. As the schedule number increases, the wall thickness and pressure handling capacity also increases. So this is the relationship between pipe schedule, wall thickness, and pressure capacity. It is very clear that as the pipe schedule increases, wall thickness increases and thus the pressure handling capacity. Now, what are the various materials that can be used for piping? So, carbon steel, stainless steel, cast iron, copper, PVC, okay, then CPVC, HDPE, FRP, glass line steel, and many other materials. Now, let us discuss some major piping design problems. So, piping design problems are the practical challenges that we face while designing a piping system. So, when we design a piping system, we need to ensure the safe, efficient, and economical transportation of fluids in a chemical process plant. Now, these are some major piping problems. So, first one is improper sizing. This can cause excessive pressure drop or low flow rate, either way. Second one is high pressure drop, increasing pumping power and operating cost. Third one is thermal expansion. So if there are temperature changes that are occurring in the fluid that is flowing through the pipe, then pipe expansion or contraction can take place, which can lead to stress and possible failure. Fourth one is excessive pipe stress. So due to internal pressure, external loads, vibration or thermal effects. Next one is corrosion or erosion in pipe. So we need to ensure the material of construction is corrosion free or has higher corrosion allowances. Then improper pipe routing. So we need to see the route of the pipe. That is, if we are not having a proper layout of the pipe, then we might end up with either longer or shorter pipes. Then inadequate pipe support. So if the piping supports are minimum, then there is chances of vibration, mechanical failure, or pipe bending down. Leakage at joints and fittings, that is also an issue that has to be taken care of. Pump cavitation. So if it is caused by poor suction pump piping design, that can lead to damage of pump and reduce the performance. And last one is water hammer. So sudden pressure surge due to rapid valve closure or pump shutdown, which may damage pipes and fittings. So these are certain problems that has to be taken care of or need to be taken in mind while designing your piping system. Now let us look at what are the measures that should be taken to minimize the piping design problems. First one is we should select the correct pipe diameter. Then we should minimize the pressure loss through proper layout. We can provide adequate pipe support and anchors. Okay, we should allow flexibility for thermal expansion using expansion loops or joints, and we should even see if there is possibility of compression. Then select suitable pipe material to resist corrosion. Then we should use proper valves, fittings and gaskets. Okay, improper use will lead to leakages or even you can say pipe leakages, fluid leakages, or pipe can even burst out. Then we should definitely follow all the standard codes such as ASME, API, IS. In summary, if we discuss about piping system, so piping is the backbone of a chemical process plant. It ensures the safe and efficient transport of process fluid. Pipe strength depends on material, wall thickness, diameter, operating pressure, temperature, and corrosion allowances. Wall thickness is selected based on pressure, temperature, pipe size, material strength, corrosion allowance, and safety factors. Pipe schedule provides a standardized method for specifying wall thickness, helping engineers select pipes suitable for different pressure ratings. Proper piping design enhances plant safety, reliability, efficiency, and overall plant economics. Now, the last topic in this section is insulation. So first of all, what is an insulation? Okay, so insulation is a coating that we apply to our pipe or equipment to avoid loss of heat, conserve energy, okay, and so forth. So that is insulation. So why we need insulation? We need it to minimize heat loss, prevent heat gain, and conserve energy, protect personals, that is people protection, then reduce operating cost and increase equipment life. So there are various types of insulations, that is hot insulation to avoid heat losses. Then we have cold insulation to avoid or prevent heat gain. Then we have acoustic insulation. So the purpose is to reduce sound and vibration. And finally, we have a fire insulation also to protect equipment during fire. Now, what are the various insulating materials that we use? Glass wool, rock wool, calcium silicate, ceramic fiber, okay. Then polyurethane foam, and cork, and foam glass, and so forth. Okay, so what are the advantages of proper insulation? It will provide energy conservation, reduce heat loss gain, lower operating cost, improve power efficiency, personal safety, prevents condensation. Okay, that is poor pollution. Then we need high energy loss, increased utility bills, temperature fluctuation, condensation, and risk of burns to personal and to other effects that can also be caused. So, what are the factors that are considered while selecting an insulation? So, what are the operating temperature and pressure, thermal conductivity, moisture resistance, mechanical strength, fire resistance, chemical resistance, durability and service life, cost, ease of installation and maintenance, and environmental and safety requirements. Okay, so the key takeaway is that the ideal insulation materials should have low thermal conductivity, high durability, adequate mechanical strength, moisture and fire resistance, chemical compatibility, easy installation, and low cost. Thank you. If you have any doubt, you can put it in the comment section.